Hello and good evening to you all. I am Parth Varu, event planner for Microsoft Reactor Bengaluru. I welcome you all today here at Reactor Bengaluru. The session will run over next 60 minutes. And before we begin, please let us take over our code of conduct. Yeah, please take a moment to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in a way you engage. So it's on YouTube. The chat will be open to for the questions. Please feel free to add any questions on the chat section. Over to Vivek to begin the session.
Hey, Pat. Thank you for bringing me in. And I see that you're in Reactor Bengaluru.
Yes, I'm a reactor.
Interesting, very nice. You
How
have
is it
Reactor
going,
T-shirt.
Vivek? Very excited for
All good.
this session. Yeah.
Yeah. So, by the way, I'm Vivek, Senior Cloud Advocate at Microsoft, and today we are definitely going to discuss two things. One is how early stage startups can get started and how they can learn few things. And I'm going to share a couple of things which I was reading, and I will share it when in this session. And then obviously we're going to have a discussion with next term team, which is Vivek, who is one of the founding member. He's going to come in and he's going to talk about brain computing interface, something which is really interesting. I learned it yesterday. Okay. Let me bring in Vinayak uh, to the session. Hey,
Hi.
Vinayak.
Hi.
Go ahead, Vinayak, introduce
Like,
yourself.
Yeah, hi. My name is Vinayak Hegde, as you can see, and I'm the CTO in residence at Microsoft for Startups. So I help startups with scaling up their technologies, choosing the right tech stack, figuring out a good org structure as they grow, and also help them, choose components, from the Azure portfolio as well, or open source as well. And yeah, that's what I get to do, and work with exciting startups. And prior to Microsoft, I have been working with various startups as CTO and in other technical capacity, both as an individual contributor and as a in senior technical leadership roles. So that's a little bit about me.
So, Vinayak, yesterday I was reading a couple of things with respect to startups, and one of the interesting thing I found was this. Let me bring this in. So this is the one. So um, you know Microsoft Learn is not just about technical stuff. It is also about, you can also learn some of these things, which is respect to how to build a startup and how to validate things and probably how to go and pitch. It was an amazing learn modules, which is 4 hours of learning, which is there. I was able to complete some 1.5 hour or so, but I thought, okay, let me share this even before we get started with this session, so that people can go through this. I'm sure you have read this completely. Have you?
Yeah, I have. I mean, I have not just read this. I think I have read. I mean, I've lived some of this, right? I've been working for startups as well. So, as a founder and as a person has worked for startup, felt that somebody who's doing a startup for the first time, I think it gives them a good grounding, a good sense of what are the different aspects of of building a startup, especially from a 0 to 1 stage or 1 to 10 stage. The initial time when it's the hardest time when we have to kind of figure out your market, figure out your pitch to investors, build your initial team. And it actually covers all of these different aspects. What are the different aspects of building a startup? How do you validate your idea with customers? How do you get to revenue? How do you name and do branding, whether it's a logo, whether it is showing up at events? How do you choose and build your initial team? And once all of this is coming together, all of these things are happening in parallel. How do you actually to take it to the next level? You need some capital also. So how do you do like fundraising, right? How do you pitch your company to investors? So it covers the various aspects, and it does this in a very nice, beautiful package which you can kind of go through, and it's quite useful for founders. I've learned a few new things myself, having been from this background. Yeah.
Definitely. I think it's a very good learning, and I was able to complete 1 hour. And as Vinayak told, it's very informative. If you are interested, just go to that link, which is aka.ms Scale Up Thursday, and there is a specific QR code as well if you want to go and take it up and read through it. And the other thing which I just wanted to touch upon with you, Vinayak, is if I am a startup and I know that there is a program called uh, Founders Hub. Can you just spend some time on this so that people know what is Founders Hub and how to get benefit out of this Founders Hub? What are the benefits? So from a startup perspective, I'm an early stage startup, so how do I get benefit from this? Even if I have already built something, and how can I use this kind of a platform?
Yeah, so I think Founders Hub is our like product, a public facing product where startups can nominate themselves, and we ask a bunch of questions, and once those questions are answered, you get access to a whole range of benefits. You get access to Azure credits. Depending on your stage, you get access to $1,000, $5,000, $25,000, or all the way up to $120K, right? $120,000. Azure benefits are just one part of the deal, right? You could also get access to GitHub. You get access to the Power Platform, which are some of the other products other than Azure in our platform. You get access to Office 365, M365. So this is just a Microsoft part, but we also have partnerships with other third party, and we are continuously kind of increasing the number of partners we have. For example, you get access to OpenAI, right? And your startup can get a couple of consultations with the OpenAI expert who will actually guide you through your OpenAI journey. You get access to OpenAI credits. So there are a bunch of other partners. I mean, in the sense of time, I won't go into all of these. So there's the credits. There's obviously the partnerships, and you get access to those. In addition, we have access to support. So as you're building, you maybe run into a glitch, or you need some advice on how do you architect your stuff, or if you are in, let's say, a fintech or healthcare, what are the security and compliances that you are needed to do. So we look at architecture, we look at product base, we look at general architecture, we look at how do you build, what are the best practices around building some of the products, and what we have seen from different. So I get access to Azure Technical Advisor, you get access to App Consultant. All of this is part of all of this is part of through the portal. You can also raise support requests, all of that you will have access to. You also as you go through the journey, we'll also guide you. So on the business side, so we can help you kind of list on the Azure Marketplace, and then you can use Azure Marketplace to sell your product in a plethora of countries. So pretty much Microsoft is present in every country, pretty much every country in the world. So it takes care of all of your billing. So if you have like a SaaS product, you can either list it, or you can do the transactions as well. So, and everything is handled by the platform. So it gives you a whole range of access to a market that early stage startups typically find it hard. As a startup gets bigger, we also have access to post-sale. So Microsoft has a large number of sellers, and we actually incentivize them to sell your product for you. Obviously, there's a process that you go through. There's a certification. We make sure that it adheres to all of the industry certification when you're selling into a certain country. And startups have got a huge amount of benefit, selling through the sellers. And the best part is you can think of it as channel sales or an extended sales team. You have to build some collateral and other things. But once you've done that, then you can get access to a whole lot of deals, which would have been harder, and the sales cycle would have been much longer had you done that yourself. Right. So this whole, I mean, we do like a 360-degree view. And last but not the least, we also have introduced this new facility where you can get access to mentors, and you can basically go through directory of mentors and choose and connect with certain mentors who can give you access from how do you do your fundraising, how do you do your pitching, review your pitch deck. They will talk to you, help you with like architecture. They will help you with specific queries you have in an industry. They can tell you about the ecosystem, or the state of certain verticals or maturity to certain ecosystem in a certain country or a region. So you get access to the entire kind of, say, I would say, uh, experience of the people inside Microsoft and outside as well, through the mentor network, and we have found that we have got like a very good rating, and that has been like one of the USPs. So I think it's not just about the credits; it's all of these like partnerships, helping you kind of on the tech side, and as part of my job, I also we run different programs. And we also on the marketing side, for example, we have we will host you at certain events, both online and offline. So this we look at helping a startup grow very holistically.
Got it. So anyone can apply. Anyone with an idea.
Anyone can apply, and
So that's pretty easy. That's just go to
yeah,
that Founders Hub link, which is there, and there is a 4-step application form. You can see that from the slide. There is 4 steps, and once you're filling it, and in the last step, you can obviously give this reference email ID, which we have put there, which is scaleupthursday@microsoft.com. And if you just key in that, you're also being referenced from us. So go ahead and try this out. It's open for everyone. So if you have an idea, you want to go out and try something, just apply in the Founders Hub and get yourself a credit and probably build that idea and build a startup. So that's the easiest path to build a new startup. So let me bring in the one of the startup which is part of the community, the Founders Hub community, and Microsoft for Startups, which is NexStem. So I'm going to bring in Vivek. Hey Vivek,
Hi everyone. Hello.
how are you?
Yep, doing great. How are you?
Doing good, doing good. So let me try to introduce you. I mean, it's kind of difficult, but I'm trying it hard because how many hackathon winning 20 hackathons?
Yep.
20, 30, 20.
Yep.
Am I right?
I guess more than 20. Yep.
You're 20 hackathon winner. Okay.
Um,
And 15 certifications, uh, s- 15 certifications on Azure. I mean, not just Azure, probably in cloud you have,
yep.
right? So that's amazing. And VP of NextEm, amazing. So yeah, and welcome to the show. And
Thank
obviously,
you.
I'll let you introduce yourself. You are the best person to introduce yourself.
All right. Thank you. Thank you so much for having me in. And just to have a quick intro about myself. So currently, I'm a VP of product at NextStem, and I'm 16 times multi-cloud certified. I'm mostly certified in Azure. So when it comes to, I would recognize myself as a machine learning person. So the certification journey started with data scientist associate, then it forwarded to AI engineer, then developer associate. So I expanded my sphere on Azure with that. Then following on, I have a very good community side for me as well. So I run Azure Developer Communities in Tamil Nadu, which is in India, and I usually very much present in Microsoft Reactor Bangalore. So most of the weekends you can find me there. I'll be either a speaker or attendee over there as well. And besides that, I'm a Guinness World Record Holder as well as an AWS Machine Learning Hero. And yeah, most of my college days have been spent in hackathons. So I participated in around 60 to 70 hackathons and won around 20 plus. Now I transition my role from an attendee to a mentor and a judge in hackathons. So that's the journey so far from my end. Yeah.
So this is the main reason why I told it's very difficult to introduce you.
Thank you.
Okay.
Yes.
Let's get started. Okay. So, uh, what's the journey with next term?
Yes. So I've been associated with NextStem since December 2020, but the actual startup actually got started in August 2020. So, but this idea has been being groomed from a very long time by two of our co-founders, who is Siddhant Dangi and Dipanj Goyal. So, from since their college days, they have been working with a tech called brain-computer interfacing. So, just to give a glimpse on what is brain-computer interfacing, if your computer can access or control an interface or device or application, then that's brain computer interfacing with just your thoughts. So as Nextem, what we actually do is we provide you a platform where you can control any application or any devices that you want to control with your brain thoughts. So that's amazing tech that we have been building so far. And um, so this is a journey, and they have been doing this since their college days. And once we actually matured our idea, then only we actually shifted from being just an idea to a startup. And then we entered into Microsoft Startups Program and Founders Hub. And since then, we have been receiving amazing support and creating wonderful stuff in Azure as well.
Cool. I mean, that is like really fascinating, right, Vivek? Yeah, and now I think one of the reasons I think Vivek has me, though my name starts from V, is I think to differentiate between the two Vivek. So unless when I say Vivek, I'm mostly referring to you, Vivek, Vivek Raja. Like call out the other Vivek. Yeah. So yeah, it's coincidental that the first in the series and all of us have our names. We have two Viveks, and the other
Starts
one is
with
also starts with V.
V.
Yeah, so I think fascinating journey, very interesting product. Can you tell us a little more about the tech as well? Like, a little bit about the stack, how you built, and also maybe a little bit about the product, and then we can take it on from there.
Cool. Yep. So coming to NexStem, so as NexStem, we are actually a brain computer interfacing company. So we build BCI as a service, as a platform. So any company who wants to create a wheelchair that wants to control via your brain, or it can be your Windows Cortana that wants to be communicated with just your thoughts, not your voice communication, then this is the platform, or this that's where we come into picture. So this comes with two things. One is our hardware, which is our NextStem headset, so which is capable of capturing your brain signals. And the software tech part will actually take care of predicting what you think. And it will help you to seamlessly connect with any external device that you want to control via brain. So with that being said, let's take about our two products, which is our NextStem headset. So it has got 16 different electrodes that captures from different parts of your brain. And it's as easy as just wearing like this. So you can just wear your headset like this, and all it takes for you to now you will be able to stream and see your data and your brain data coming live in your screen as well. So that's the capability of NextStem headset, and it has features of transmitting around 1,000 samples, nearly 1,000 samples per second data stream, which is like a huge number of data that is being transmitted, which means we will be able to predict your data very accurately. And next comes our brain computer interfacing solution, which is our Wisdom SDK. So that's a place where a person with no knowledge of programming or research or even brain computer interfacing will be able to create a brain computer interfacing application within just minutes. So that's the power we are actually handing over to the hands of a common person. So here is where you can actually see your real-time data of your brain. You can play around it. You can then create your application that can actually be in brain control. And then with just few lines of code, you'll be able to seamlessly integrate with your application. So that's what we built here at NextStem. And yeah.
Yeah, so I think just for our viewers, I think I mean, you reference BCI many times. I think BCI is brain computer interface, right? So while it is fascinating, also I think it's also scary, right? Because we've all seen the Matrix, uh, and in one of the scary things in Matrix is that like hook that is at the back, or rather the hole that is there when you plug in, right? Uh, so at least this in this case it's like non-invasive, right? And
Yes.
so it's like fascinating and scary at the same time. But I'm excited that like and like we look at technology, right? And sometimes we realize that we are using technology but we don't realize. And as we've gone on, right, initially we had text interface, then we had the keyboard, and then we had the mouse, so all of these has evolved, and we are using voice, and then there's been touch screen, and now it's like the brain computer interface, which is like fascinating, right?
Yes.
And also in some sense scary, right? Like, but also I'm thinking like, how far are we from maybe like learning new skills, like for example, can I like attach a USB kind of thing to my head, and suddenly I am become an expert in, like, say, karate or take taekwondo. That would be like fascinating. Like, so it's like almost like sci-fi come true for us. And that's definitely fascinating. So we have talked about a product, and we have obviously talked a little bit about the SDKs. Maybe what we can do now is also maybe jump a little bit into the applications area a little bit, and figure out what kind of applications would make sense. Uh, yeah.
Yep. So just to touch base on the few points that you actually spoke. So, yep. BCI will be one of the futuristic way of communication in future. So we have evolved from using keyboards to mouses to controllers. Now we have voice assistants with us. So we have Alexa, we have Cortana, we have Siri with us. And the next level of is where we'll be able to communicate with just our thoughts. So that's the way we are actually moving forward. And coming to the other aspects, yep, it works in two ways. One is where we collect the information from your brain and we predict what you think and we take some subsequent actions. And the other way around is where we give commands back to the brain using some electrical signals. But the latter one takes a lot of research and a lot of complexities and so. So I think I see that a little bit down the future, but of course it's in the hands, it's in reachable hands. And coming to the use cases, yep. So that's amazing. So you might now wonder like, okay, now NexStem has built a hardware and NexStem has a software that can predict what you think. So now you might actually have a lot of questions. So could I control everything that I see, or could I read someone's minds or something like that? So a simple answer, not completely. So let me put you in some simple words. So we actually listen to your brain is actually a very complex organ in your complete body. So which means it has literally named its own organ as brain. So it's that capable. So with a complex organism or organ like a brain, so there are a lot of thoughts and everything going around, but we need to specifically listen to some specific parts, like whether you're smiling or whether you want to move your arm in your left or right side, and so on. So as NexStem, we only listen to some specific commands that we can listen, and we can reciprocate that commands into some subsequent actions. So basically, one question is like, we won't be reading your thoughts, but we'll be listening to some of the very specific commands that you want to be listened to. So that's the whole point. And with that, to touch base on the use cases, there are several companies, research universities working along with us. So there are research universities from US who's actually building a neurofeedback that can actually identify whether the person is going through a depression phase and so on. So, and once that is being identified through our headset as well as our software, they'll be actually connecting to their own software device, where that will show them some happy images or happy music that will make the patient feel happy. So which means you are actually will be able to monitor a particular subject or a patient who's actually reeling through depression. And you have an enormous applications in healthcare with regards to mental health space, and even in cerebral palsy and so on. So person with very limited communication or very limited movement can now will be able to communicate easily, and will be able to move easily with just your thoughts. So your thoughts will be translated to words that can appear on the screen, or your action that you want to move your wheelchair can be communicated to your wheelchair, and it can move as well. So that's amazing use cases that we are actually collaborating with others, and companies are building on top of it.
Absolutely fascinating. I mean, yeah, I mean, also I think when we were talking before, you also mentioned that you can also track eye movements and stuff, and as well, right? And I'm very fascinated with the accessibility access also. And again, like, while this might seem like more sci-fi, I think there are it does seem like magic, right? Like, as Alan Key has said, like, any technology that is sufficiently advanced is almost indistinguishable from magic. Yeah, so that quote comes to mind as well. So maybe you can talk about some of the eye tracking application and the things that you do with accessibility as well.
Yes. So when it comes to NexStem, so we have spent a considerable amount in research and technology. So the product which you see is just one tip of your iceberg where you can work with it. But that opens up a door where you can create enormous applications or put your own thoughts to it. So as NexStem, we have also built in some in-house algorithms or in-house use cases that you can sync up with your devices or your applications. So for example, one is called motor imagery. We can identify what sort of motor actions that your body can do. So it can be like, if you imagine moving your right arm or left arm, or even if you imagine moving just your left finger or blinking your eye, or any body part that you want to move or imagine, we'll be able to precisely tell you which you are actually moving it. And that is where we will be able to identify your body movements, and that can be used to move your wheelchair or do a lot of amazing activities. So a person with restrictive movements can just imagine about moving their body part, and we'll be able to actually tell you which the body part the user wants to move, and that will help you to actually reciprocate into actions. And the second one is like we can actually identify what sort of facial expressions that you show. So, for example, you can smile, you can be angry, or you can frown your face, you can clench your jaws, or you can grin, or you can even cry, or you can do a lot of stuff. So all these expressions that you can communicate with your face can be easily captured with just the device. So we don't use any cameras or any external capturing device. With just this headset, we'll be able to precisely tell you what sort of facial expressions that you show. So that is one use cases, and with that, we'll be able to identify what sort of expressions that the person shows. So whenever I want to smile, I want my lights to go on. So that can be one use case. Or whenever I feel like I need to, I feel a little bit sad or start to cry, I want some lights to be dimmed so that I feel very happy. So those are some use cases that you can build along easily. And moving on a little bit, we can even identify the emotions you show. So a person who's angry or a person who is actually happy. So all these emotions or fear or scared or so and so, we'll be able to precisely tell you. So a person who has a non-verbal ability or not able to actually communicate what they feel, we'll be able to precisely tell what sort of emotions a person goes through. It's just not just limited to your external emotions. It can be your internal emotions like your depression or anxiety or stress and so and so. So we have built these algorithms where you can seamlessly integrate. But the best part of NextStem is we have opened up the opportunities and platforms where you can actually build your own use cases on top of it. So if you have your own emotions that you want to be detected, you can build it. Or if you want to even invent a different domain in your BCI, you can even do it with your seamlessly available features such as experiments and algorithms, and you will be able to do it with ourselves. So that's a open-ended possibilities that we open with NextStem platforms.
No, that's
So
fascinating. I mean, yeah, like you're talking about accessibility, but I just like a note on accessibility, right? Like accessibility is not just for people who are constrained by their senses, like people are blind or people who are in wheelchair, but even something as simple as, for example, subtitles, right? Subtitles started as an accessibility features, and today,
Yes.
I mean, I for example, we watch everything on Netflix and other OTT providers, and we use subtitles. So they are kind of a given, and it's even easier for us, like people who are accessibility helps everyone. And I'm just letting my imagination run wild here, but like when you were talking about you can think of it, and it in some sense it will happen. I was thinking, like my mind was running wild, and I was thinking of all of these like uh, uh, sci-fi movies where you have an exoskeleton like Transformers or those kind of things, right? Like you have an exoskeleton and you can combine it with robotics, and then you can actually enhance ourselves. And while we might see very far-fetched, maybe like at 10 years down the line it may not. Like for example, all of us are wearing glasses. Glasses
Yep.
was at some point like was technology, right? But all of us were like born after, like way after, like glasses were invented, right? Like seeing glasses, and we never think of it as technology, right? So somebody had this like beautiful quote which said, anything that happens or like that is invented after you're born is like technology, right? We never think of spectacles as technology, but when you think about it, it is actually technology. Yeah,
Yep.
so with that, I just want to kind of go peek a little bit behind the curtain, right? This is like what the user facing is. Maybe talk a little bit about the architecture, how you kind of build this all together. What are the
Yes.
components that you use, and kind of so give us a peek behind the curtain about how it is all kind of coming together.
Yes. So NextStem has a very holistic, a simple architecture, but very powerful one. So this has been iteratively improved over a course of time, and we have taken help from our Microsoft Startups team, where we have architecture reviews and architecture meetings where they help us to enhance in every single bit of it. So if you want to actually put NextStem or the whatever the services which is running behind it into three main categories, then I would classify them as one as IoT, where it primarily interacts with your devices. And the second one is your application, where it controls all your streaming and or how to host your website and so and so. And the third major part is where of course, where we predict you what you think. So that's a very complex machine learning stuff which is running over there. So I made this architecture diagram as simple as possible so that to give a very good idea about how data transfers or data moves from one place to another. So the data originates from your NexStem device over here. So we'll also see a simple demo how it actually works as well. So we provision your device using IoT Hub and we maintain all your devices over there. And then we have something called Kubernetes service, which is running, which is nothing but a place where it actually receives your data from your devices. So your device can be anywhere, which can be running in Australia or in US or from India or anywhere. So that's a single first point of contact where we receive the data from your end user to your our cloud architecture. So once our data is actually received, we use WebPub. It's a Azure service which actually helps you to facilitate all the WebSockets, and it streams all your data at very high rate. To just to give a glimpse of how much data are we actually streaming here is about 16,000 data points every single second. So because you have 16 channels and there is a sampling rate of 1,000, which is like 1,000 data points, or to be even put in a simple words, we stream around 1,600 data points every 100 milliseconds. So that's an intensity of the data we are dealing with here. And all we need to do is we need to keep it under 200 milliseconds. So this is the biggest challenge that we need to solve, and this architecture actually solves that issue as well. So we have WebPub to stream your data, and we store it in blob storage. So we have a lot of data recordings coming in, and we store it accordingly to there. And then we have another backend service. So we use app service to seamlessly scale up and scale down depending on the load. So there is two major app services which is running. So one is your backend, your stream service, which manages all your stream, like where your stream should come, when it should start listening to the stream, and so on. And there is another backend service which controls all your APIs. So typically, or how your real backend works. So it takes up your API commands and it proceeds on forward. And it tightly interacts with your Azure database, which is Postgres SQL, which we use. So we store all our user information, all our transactions, and everything over there. And we authenticate users using Azure AD B2C, and that has helped us. We have used custom policies where we have a long range of sign up and sign in policies that we need to undergo. And even at the beginning of the talk, we also mentioned, since it's a healthcare, we need to comply to a couple of health as well, health related compliances. So we make sure that we added custom policies where the user has to check in before agreeing to share the data or use the data according to our platform policies as well. And with that being said, now we have data in place. Now we have a web application that you can see. We use another app service where it serves all your static files like your CSS, HTML, JSF, and so on, where it typically runs a React framework over there. Then comes your major chunk, which is your machine learning service. So whenever the user initiates that, he wants to train your data. For example, if I want to train my data to control a wheelchair or to move forward, backward, left, or right. So that's where your spark of your machine learning comes into picture. So we use two services. One is your training your data. So your backend is completely isolated from your machine learning services using your message queues and message topics, so that your backend don't need to know about what's happening over there. And once we receive all your machine learning requests and jobs, then we use Azure Machine Learning Service to run it. And we use a serverless function to monitor how that actual machine learning jobs execute. Once that is done, then we can actually have your ML in container app. So that has your inference service. Then you can seamlessly interact with that and you can receive all your predictions in real time. So I think that gives you a complete overview of how NexStem or this NexStem Wisdom SDK actually works behind the screen.
So Vivek, I have just one question here. So you don't do any edge computing at the device, right? You just take the data and you just stream it to IoT Hub.
Yes, exactly. So right now, all our streaming architectures are in a way like it's from edge where you have the device, it streams completely to the cloud. So cloud takes care of all the processing, maintenance, and all the necessary processing that it requires for the data.
Cool.
Okay.
And also, maybe can you tell me like what kind of language ecosystems are you using as well? I saw that
Yes.
there's JavaScript for sure because you're using React, but what else are you using for processing?
Yeah. So for backend services, we use Nest.js. So that's a comfortable framework we have chosen, and React as our front-end framework. And we use Python for all our machine learning services and so on. And to be put in fact, like all our Kubernetes or services have been spinned up with just a couple of lines of code, which is few done using UI and few done using Terraform to automate all our architecture stuff. And basically, that's a complete programming tech stack that lies behind it.
Interesting choice. Because generally, what I've seen is if you're very highly sensitive latency requirement, people actually choose maybe like a statically compiled language, right? Like maybe like Rust, Go, C, C++, C Sharp also, or Java for that matter. And I think you're using more on the dynamic side, which is like Python, because I think Python has also very good support for machine learning in terms of libraries as well, and also like JavaScript, right? And I think very interesting fact that I want to call out is that you are using JavaScript in the front end, back end, so I think it helps you kind of keep the surface area of the skill set that you probably require is also low, and then you have good support. I think as you scale, maybe some of those decisions might get possibly revisited as well. But yeah, find interesting piece of insight that I just wanted to highlight.
Yep. And adding to that, actually, so the reason why we were able to comfortably use JavaScript related frameworks for all data processing, of course, that's not the best or the first choice we go on, but most of our hard lifting of our data streaming and data management is taken care by Azure itself. So all your backend services does is just take it and put it on the screen. So that's the reason we were able to perfectly balance out that data streaming part. And with that, Azure services ensuring that we can actually deliver the data within 200 milliseconds, that gave us an immense window for us to work with JavaScript frameworks actually.
So Vivek, there is a question.
Yes.
It's on the screen, but so basically the question is how you balance your writing your custom code versus using Azure architecture or service.
Oh, okay, that's interesting. So the reason is like we ourselves, who is like a hardware plus software company, so we have to write a lot of custom code that goes behind the screen. So for that, actually, what we use is we combine those custom code with our app services, which needs to be tightly coupled, and that includes like our signal processing techniques and so on. So and actually, to also add to the question or answer that we had with Vinayak, which he posted a couple of minutes back. So, in the sense, like we use C++ for one of our complex signal processing pipelines as well, and that is tightly coupled with our JavaScript frameworks. So that's where we will be able to manage our custom code. And when it comes to using Azure services, yep, that's a choice that we make. So we do a lot of experiments and POCs where we evaluate different services and their capabilities, and we also ensure that whether it meets our criteria and threshold. So only when it does, we actually go for the necessary stuff. And to our fortunate circumstances, most of our Azure services actually cater to our requirements. So we stuck with that. And of course, if someone is actually managing your services and ensuring that it's always available, I would happily go for it as well. And that's the main choice.
No, this is a very
So-
to add to what yeah, sorry, to add to
No,
what
go ahead.
Vivek Raja said. It's very fascinating, right? I mean, as a CTO, as an engineer, I also always have this debate: should you kind of own and control every piece of your architecture and your code, or should you kind of outsource it? It's constant like build versus buy or build versus use kind of thing. And especially, I think when I talk to early stage startups, I often tell them that, hey, you know what? For you, I think. Not cost, but in some sense, I would time is your biggest enemy, right? And so you would probably want to kind of experiment and see where it goes before you kind of try to, before you go ahead and try to make a decision whether to optimize it or not. And that really makes a difference, right, between the speed of building. So maybe you can try maybe some of the services and see how it works, how it scales, and kind of outsource that work completely and just focus on the product, see where it goes, what your customers want. And then if you feel, oh, that is becoming a scaling problem or that is becoming a cost problem, you always have the option to kind of go and rebuild it, right? But I think you have to, in early stage, at least you're optimizing for speed and not for efficiency or cost as much. Because I
Yes,
think
exactly.
programming cost and learning also has a cost, right? That is in some sense a hidden cost. And especially I
Can I-
think when did it beautifully well, right? You are a hardware startup, and you're also building software. Like, there are only so many things you can do. So why not just build on what other people have built? Yeah, Vivek, you're saying something.
Yeah, it's basically also maintenance.
Yeah,
It's
maintenance as well. Yeah.
maintaining is also a overhead, and as a startup, you would love to push that maintenance to the provider, right? That will be one of the things. Vivek, I just wanted to check with you now. After seeing this architecture, how many Azure services you use? What all Azure services you use?
Yep. So just to go through, we have IoT Hub, we have web app service completely. Like there are multiple app services which caters to backend, front end, and even multiple backend services as well. Then we have blob storage for storage. We have Kubernetes service. We have container app service. Then we have Postgres for database. Then we have service bus queues and topics for message and transversal. We use Azure Machine Learning Service and all its compute and storage capabilities for all our machine learning, this one. And we use serverless for all little bit of monitoring and Azure ADB2C as well. So besides that, this is our product actually built. But for even for team productivity, we even use Microsoft products, and we are inside Microsoft ecosystem. So we use Azure pipelines for our CI/CDs. We use Azure repos to host our repositories. We use Azure boards to maintain our task and issue management. And we use Azure test plans to run unit tests and automated unit test runs and as well. And we use Microsoft Teams for our internal communication. And basically that sums up our whole Microsoft ecosystem. And we extensively use Microsoft 065 for our documents, Excel, PowerPoints, and so on. So I think we are one company who have jumped exclusively into Microsoft ecosystem, and we have probably utilized all these features to the fullest.
Great to hear that.
Fantastic. I lost count after 10 plus. It's like it went on, so I lost count. But it is definitely 15 plus. Thank you. Yeah. Uh, can you just touch upon what were the challenges you had in terms of obviously when we were discussing, you told how how this whole thing was built initially, and then you changed this architecture. So can you just touch upon that?
Yes. Building a SaaS platform or SaaS product is completely different from building a hardware plus software startup. So we need to include a lot of capabilities, and we need to understand the limitations of your devices and its capabilities as well. So only when you accept and you understand, you will be able to build a product that can satisfy to its needs on the software end. So our device is capable of streaming your data, but to handle that much of a data stream is where the actual challenge comes into picture. So probably we also discussed that the main requirement is like we need to stream around 1,600 data points every 100 milliseconds, and we need to keep it under 200 millisecond latency. So the first challenge that we initially faced was building a good data streaming architecture. So of course, we use IoT Hub for provisioning, and even IoT Hub provides you event hubs for your data transmissions. So, but we faced initial trouble in maintaining devices, and to have event hubs for like a topic for every single device and maintaining that. So basically, at one point of time, when you reach more than 50 or even more than that, then you have to create multiple event hub namespaces to cater to it. So that's not an optimal choice to go with. And that's where we come to a place where we'll be able to filter out and recognize messages from different devices. But then filtering out and maintaining different streams and maintaining it in your Kubernetes service or storing that in your blob storage has become a headblock, or we reached the bottleneck over there as well. So that was the second roadblock. Then we started experimenting using web PubSub. So this is one of the interesting use cases that people can even consider. So that's where your region, your availability, everything comes into picture. So when it comes to web PubSub, it extensively works flawlessly when all our backend service and our headset and as well as our web PubSub resource is hosted under a single region. But once we noticed that a user from Australia or user from Europe started using it, we noticed latency delay more than 500 milliseconds. So, yep. So again, we are not able to meet our criteria of keeping the latency below 200 milliseconds. So now the web PubSub, now we understood that the web PubSub works very well within a region, but of course, keeping it load balanced across multiple regions might not be the optimal solution. So now came the final version of our solution is where we use a Kubernetes service that will listen to your UDP connections or your data streaming connections from your headset. And the best part is it can keep your latency well below 100 milliseconds. So Kubernetes service hosted in US can listen to any headset from any region with very minimal latency. So now your data is in central US. Now your web pub sub is also in your central US. Now you have solved your latency problem, which can now easily communicate well under a stipulated latency. So that's why we opted for this particular architecture where a Kubernetes service hosted in central US can listen to any devices from all around the world, and then it can pass on the data to your web pub sub, and that will stream to your backend or to anywhere else that needs to be done. So that's how we solve this data latency issue. And of course, it came with a lot of POCs and a lot of iterations and a lot of architecture reviews that went along with startups architecture team, as well as us doing a lot of POCs to see what really happened.
So you mean to say you have a Kubernetes service listening to your devices? Which is that
Yes.
service? Like, is it your API or is it a certain service you're using?
Yeah, it's a service that it opens up a secure connection once there is an intimation from the backend. So backend is where it actually starts you to connect your device. Then it intimates your Kubernetes service that there is an incoming connection, and then it opens up the necessary ports and your this one, so your device can start streaming to that particular port. And then that's the first point of contact of data receiving from our headset.
Got it. Any other issues you had faced? Any other challenges you had faced?
Yeah, so basically, IoT Hub and the data streaming was one of the very difficult challenges we faced initially. And coming to our Azure machine learning, so that's one primary component that came later on the architecture, but it played a very primary role. So when it comes to Azure machine learning, and myself who has been dabbling with machine learning for a long while, of course, discovered a lot of success and challenges within that. So it helped me seamlessly listen to training job and initiate training job and keep it under cost optimized as well. So we use compute clusters, and that helped us to keep scale up our VMs only according to our ML job request that incoming requests. And of course, to maintain our Azure ML workspace, we used machine learning pipelines to make it very much easy. And also the monitoring service helped us to understand where the job and everything machine learning service goes on. But the issue which we face a little bit is with the published pipelines, where we were actually experimenting a lot with published pipelines, and we created a lot for development environment, and it actually cluttered a UI space where we're not able to actually delete it back. So that's one of the hindrances that I faced personally. And though it was not affecting our workloads or protection, but immensely, I was very much happy with working with Azure ML in overall picture. And our app services always ensure that it's always live and available. So anywhere, if there is a spike in traffic or something, I don't really need to care about load balancing or increasing the servers or so on. So it does it everything for me. So that's where I, as a solution architect or a person who actually does it, feels very comfortable and happy and safe for that.
Audience are eager to see this as a demo. See, I mean, I can see that.
Oh, perfect. Yep, sure. We can
Let's see.
hop into a simple demo where I can show you how a Wisdom app looks like. So for people who wants to do it completely non-code, low-code approach, then your web app is your right place to hop in. Or if you're a person who likes to code a lot and you like to dabble with C++, then we have our Linux and our Windows versions of our available. So you can immediately download our SDKs and you will be able to access that as well. So how easy it for us to actually connect our device and stream it? That's what we are going to see right now. So right now my device is 30, which I'll be actually connecting to it. So once this is the NexStem 30 device, which is actually I'm wearing right now. So it takes time to connect and make sure it works. Okay, I need to log in back because maybe the session has ended. So let me log in back. So this is where your Azure AD B2C really comes into picture. And the best part is you might notice that you can customize your UI, and all it takes is to drop-in UI place and a CSS page, and that will reflect back in your ADB2C. So you don't really have to code any login pages by yourself. So Azure does it for you. So coming back to our connection, so let me connect it back.
Can you just zoom in as well?
Yes, I can. And let me hop in up. This will actually look pretty much good in your this one. So this is our 16 channels of a headset. So basically that reflects our device, which I'm actually wearing. So all the 16 devices which you see, all these electrodes is where your devices will be taking our data. So I'm wearing right now, and let me start plotting it. So what you actually see on the screen right now is around 16,000 data points coming every 100 millisecond all around the world. So right now I'm sitting in India and I'm streaming my data, and you can see how flawlessly and how fast it is able to stream and plot your data on your screen. So this is my live EEG data, which is my brain data actually coming on the screen. And if you're a person who likes to dabble with multiple this one, so if you're a person who likes to do FFT, this is an FFT plot. And if you want to do it in different phases like alpha, beta, gamma, so there are different frequency band. So a person who is a researcher and wants to actually see multiple plots going on, he can just hop in and see immediately like that. So this is my brain activity, I guess. Right now, since I'm talking too much, I guess it's having too much of brain activity over here. And coming to filters, where we can actually dabble with a lot of filters where you can process your signal processing. So when it comes to data, it has a lot of noise, right? So you can actually seamlessly add your filtering of your data as it goes, and you can update the plot immediately. So that means your plot gets immediately reflected. And the best part is you can't just stream, you can even record your data, and you can play back it whenever you feel that you want to download or see the data as well. So this is where you can actually record and see the data, and this is a visualization module. And coming to experiments, so there are a few persons we asked, like, could we actually listen to all the commands? So the answer is no. That's where we actually created experiments where we will listen to very particular commands. So that commands can be specified by you as well. So motor imagery reflects how much the movement of or imagination of your body part. So I can just show you how that experiment easy looks. So I'm just going to preview that experiment. So yep, it gives you all the instructions how the subject should go through, but let me skip it and start. So now I'm doing a facial expression demo where I'm focusing on sad, I'm focusing on relax. It's asking me to focus to make a surprise emotion and so on. So you can even configure the complete architecture where you can configure how much time the instruction should show or what sort of instructions should show as well. So if you're using facial expression, you can even go for your own facial expression that you want. So that is sort of an flexibility and the customizable features that we give for that as well. So probably I can say that NexStem is the only startup that allows you to create your own custom experiments, and you can train your own custom BCI experiment recording as well. So that's the thing we do. Yes.
Yeah, so quickly I wanted to chime in. So when you are doing this experiments is or you want to run experiment, do you actually like export a model, or how do you actually go about creating a new experiment?
So creating an experiment is absolutely very easy. So what we will do is like experiment is a part where we actually collect data from the user. So we ask the user to perform some actions, and we actually note down, we collect the data marking to the particular actions the user do. So the next module is algorithms module, is where we actually train and we understand, okay, so these action means these sort of data that the user has exhibited. And once that is done, you'll be able to seamlessly deploy. So how easy for us to actually customize an experiment? So I can select the type of experiment, I can create it. And now I can configure like how much seconds that your instruction should appear, and what sort of instruction that you need to actually have it over there as well. So I can configure it. There is 4 classes, which means that says that I need to have it as left faced. That means the instruction is that I need to close my left face. You can even configure what sort of animation that you even want to have. You want to have a cube, square, circle, and so on, so, or what color or what sort of size you want, so that you can even configure how that experiment looks like. So you can, so what really happens is like you give some commands, and when the user actually performs that experiment, you expect the person to do that particular instruction, and that's how we capture the data. So this is where all the data capturing comes into picture, and how easy for us to actually train the data. So yep. So you can see there are multiple training jobs which have been executed. So there are a few things which mentioned as trained. There are a few things which mentioned as it's deployed. Few things have failed, and so and so. So you can create a training job, and I'll say, like, let's assume like it's Vivek demo, and I'm going to train a motor imagery experiment. So I'm going to click it as create. So what I'm going to configure is I can configure all the hyperparameters that you want to do for your machine learning. So all it takes is like we give you all the enough information, but we suggest you the best information that you can have. And once that is done, you can select the data and you can start the training job. So it's as simple as actually creating and starting the training job. Then how you can actually deploy it? It takes only 1 second to actually deploy your training job. So let me create a simple pipeline.
And this all deployment is happening one in real time and also to with Azure ML in the background, right?
Exactly. So your training job is where your Azure ML comes into picture, and your container apps comes into picture when it comes to deployment. So I can simply add a model, and I can actually add a model to it and configure that as well. So yep, let me switch it back 1 second. Yes. So coming to deployment, I can add as many operators. So I can even add select channels, I can add filters, and so on. So I can actually create a complete data processing pipeline in that. And I can even add the model which I can really want to predict as well. So once that is done, so it looks something like this. So there are like few things where this is a pipeline which is deployed. So it has a machine learning model already in that. So based on that, we have chosen a model, and that's it. So all it takes is just 3 operators to deploy your model. And once that is done, you will have something like this. So let me show you that particular, this one. So, yeah. So coming to our deployment, so there you have something called API keys and pipeline. So all it takes is like you will give you an API key and will give you a pipeline, and just writing a 2 lines or 3 lines of code. It's nothing but connecting to this WebSocket with our API, and you'll be able to receive your predictions on the go. So it's that simple, and all it requires is one piece of code to connect to your any application that needs to receive your prediction, and that can do it. So hardly we spent around 10 to 15 minutes to actually create a whole application where we visualized the data, we recorded the data, and we started a training job, and now we deployed it. So that's simple. It's actually that simple for you to actually create a brain controlled application with us. Yeah.
So also, can you talk a little bit about, say, the calibration, right? I mean, while we were talking before that, once you have the applications out there, I mean, and say multiple people want to use the application, how would you like calibrate for something like that?
Yeah. So let's assume like you have built a wheelchair. So for a person who wants to control it. So once your model is up and ready, so all it takes is one API key and one pipeline. So that will be unique to a particular person to connect that to a particular wheelchair if he wants to control that. And one piece of code is where whenever there is a prediction of up, that means you have to move your wheelchair forward. And if it's left or right, you need to move your wheelchair accordingly. So all you need to do is write a simple if or else use case, and that will control your servos motors or whatever it does in your wheelchair. That is completely on your side. So then once it is done, now the person is wearing your headset, and now he thinks about moving forward. That command goes to your prediction, and we use our container apps to predict it very on real time, and then it sends back to your wheelchair, and your wheelchair motors will run and will control it. So that's an real-time application, and you can even think you're controlling a wheelchair with that. So yeah, that's a simplistic use case that we can even discuss right now.
Is it possible to run maybe once the model and calibration is done to maybe run it on a mobile? I mean, I know it's hard because obviously a lot of this is like customized on the server. But I'm just asking. The reason I'm asking is maybe because there might be some like offline models, offline modes
Yep.
where I mean, let's maybe like stick with the wheelchair example. For example, in this
Yes.
particular example, it would require connectivity, right? But
Yes.
let's
Yep.
say if you are like in a place where there is not much connectivity, for whatever reason. Is it possible to maybe like export that model and run maybe in a mobile app and then just interface with the mobile app and help that control or do that? Is that possible?
Yep. So right now, our current version of our headset does not support it, but we already have some enough information where the SDKs will support you on the local side. So where you
Okay.
can actually create your pipelines and locals and you can deploy it. And moving on forward, the next version of the headset and the next version of your Wisdom SDK, which you are going to see, will be
Mhm.
able to do it at the edge. So that's
Yes.
a power of running your own mobile phones in your hands, and that can do your brain related functionalities and prediction within a matter of milliseconds. And that's the power we are going to give you in next couple of months.
Yeah, so it's interesting
So,
when we typically say edge. I think we and especially with like 5G now getting more and more prevalent around the world, I think the latency and the connectivity is going to increase even more. But when we are talking about edge, we are talking typically of the network telecom edge. But what I also realize when I'm listening to you is when you mean the edge, you are meaning the real edge, like even all down to the level of a mobile phone, and that's fascinating for me.
Yes. Yep. So yes.
so
So yep. That's yep.
there are a couple of questions from the audience, so I just want to bring that in. So there is one interesting question. Um, I think we discussed this, but it would be good to answer specifically to Gopal.
Great. So what kind of commands can be given to the brain? I guess you mentioned that commands or signals can be sent to the brain also. Yes. So it's a possibility, but though NextM does not support it, so it's a possibility. So there is two ways actually we can do it. One is where we capture the brain signals and we understand what sort of commands that the brain is actually emitting out. So that's one way. Or you can even send out some specific, like basically your brain is nothing but a organ which passes around electrical signals back and forth. So when you can actually pass a relevant amount of electric signals to your brain, which means you're sending some command to the brain as well. Though that's how a couple of startups who are actually working on that as well. But next time will take some time to actually step on it. But in future, you will definitely be able to experience that feature with next time.
This is one interesting question here. Uh, how much thick hair, it will create a skew in the reading.
Wow. Amazing. Like I'm glad that this actually question came. So yeah, so that's why NextM has built an aesthetic headset. So where we have a flexibility on based on your head size, which means you can even move around and play around with your head size. So as you might see on demographical way, so eastern side we have a head size which is less, but when you actually go towards the rest you have a head size which is more. So that's why we are able to cater to our flexible headset by your flexible headset. And the second thing is coming to your question on your thick hair. Yes, of course it induces your error to it, but since we use polymer and electrodes, which is like a very flexible that can actually keep it and penetrate through your head, like you can actually touch your scalp in a very good way. We also experience that it actually induces some error. So that's where our NextM instinct comes into picture in the next headset, where we are working on some amazing mechanical and product engineering stuff, where we will be able to experience very minimal contact, like very minimal errors, and due to the contact, which means your electrodes will be in contact with your scalp, no matter your head shape and no matter your head size. So that's what we are building, and you will soon see our next time releasing that product in the market. But thanks for asking that question.
So by the way, you also sample the data, right? Like it's not necessary every data point which is coming in, you will be capturing and building using it for creating any kind of
Yes.
important skews, right? So
Mhm.
basically, you're looking at some kind of data which is sample data. So it's
Yeah.
not necessarily all the data we are capturing, and it's a UDP driven, right? Or
Yep, it's UDP driven,
so,
and the current version of headset is like it pushes all your 16 channels of data, and there we decide whether to discard or to recognize or focus on a particular number of channels for your use cases. But that's how the NextM headset works as of now. But moving on forward, the NextM instinct nothing but we are building an absolute OS on top of it. So which means you can control your electrodes to a finest level, which means I can even turn off that one particular sensor which captures the headset, which does not cater to my particular use case. So you can even control each and every electrodes of which data you want to receive, and you can work on that as well.
Got it. So Vivek, what's next? So basically, what is that? From an Azure services, what other things you're exploring, which can solve a couple of problems which you're facing today?
Yeah, so one is though we are actually moving from cloud to edge, but we do have a lot of connect to the cloud as well. So which means we are solving some issues with relevant to machine learning, because right now all your edge computing needs to be, your data will be in edge. So moving your data from edge to cloud is also one challenge that we need to solve as well. And secondly, we are enhancing our machine learning architecture in such a way like it can seamlessly work on bigger requests, and it can even cater to your custom requests as well. So which means you can build your own machine learning models on the go. That's what we do. And when it comes to NexStem Instinct, the new headset which we prepared, so it's like it has a capability of doing all sort of processing, which has had your octo-core ARM processor. That's what your mobile phone also has. So it has 64 GB of storage and 8 GB of RAM. So now you can imagine like what sort of power do you have in your hands to create your PC application. And coming to our next one is where our Athena OS, which we actually built on top of it. So all it takes is just building one Android application, and you can build your own visualization apps, your own experiments app, and you can control that with your own way of doing it. So we give fine-grained access to the hardware and very fine-grained access to the data, and you can interact with cloud for all your machine learning and other workloads as well.
No,
Cool.
fascinating. And yeah, how big a team are you? I mean, we didn't talk much about your team, and maybe you can quickly go to that part as well,
Yes.
because I believe you are a very small team that's doing all of this stuff, which is like honestly crazy, right? Like amount of
Yep.
stuff that you guys are putting out, hardware, software,
Mm.
cutting edge stuff. Yeah.
Yeah, 8 months back
Startup.
we were correct. So 8 months back we were only a team of four. So Siddhant and Dipansh, who have been working with this idea for a very long time. So me and Nitin, we believed this idea and we hopped in at the very early stage. So we were the first two employees of the company as well. So back in December, back in 2021, so we were the four who actually built the complete first versions of our headset and the product that you are seeing right now. And followed by Arvind, who is our full stack developer, who actually joined in the later part of our first Wisdom SDK, and who was driven into a couple of our major critical modules as well. And we have Ruthvi, who is our research scientist, who is the brain behind keeping our data clean and making innovations in our company. And we have a lot. We actually hired a lot of new folks in past couple of months. So we have Umang and Harsh, who is the system architects, who will be actually driving the force behind our new NexStem Instinct headset and the Athena OS that we are creating. And we have Vinay, Yashvi, and Kriti, who is our software developers who will be working on all these the Flutter apps and the Android applications that we are discussing. And Sumit is our junior developer in the embeddeds, who will be also assisting Umang and Harsh in building some amazing drivers and PCBs and so on. So that's the team we have, and everyone's an expert. And as you know, it's an early stage startup, so everyone is a stakeholder in particular field, and we are driving our whole product together.
Now my question is, as a DevOps, a DevOps background, who is doing DevOps?
So typically, right now, I was doing in the beginning. So whatever comes to the complete device and the motive and everything goes, complete credit goes to Dipansh and Siddhant. Whereas the complete things behind your machine learning and all the innovations you see goes behind Nitin, and the product facing all your web app application and everything. So basically comes on to me. So with that being said, yeah, though I won't really term myself as a DevOps expert, but I do a bare minimum to keep everything available and always up and running. Yep, that I would actually agree on that. But then later on the stage when Arvind hopped in, so he actually took a little bit of workload from me on the DevOps part, and he also maintained all our infrastructure as well. So that's how we kept the things going on.
Interesting. It's a very small team for this kind of a large kind of a product, which is interesting and really good.
Yeah, it's amazing. I mean, all the stuff that you're doing, it's a really lean team. Yeah.
And if you want to experience our product, we are in Bangalore, so you have our contacts over here. So you can just hop in and you can pay a visit to us. So we'll be happy to walk you around with the products what we build as well.
Cool. So we'll keep that on the screen for a bit. Yeah.
So, people who are in the in the session, basically, if you have any questions, just post those questions in the chat, and we can push it to Vivek. You can also ask us any questions you have. Meanwhile, if you are interested in applying for Founders Hub and everything, so just go back here and apply. This is already there. We did discuss about this, uh, and yes, go through those learn modules which we showcased, right? So definitely those learn modules are really good ones to learn couple of things, which is with respect to the with respect to getting started, if you're an early stage startup. So I'm going to bring in some questions. So there are some questions which is coming up.
Yes.
Let me do that. Oh, okay, this is good. So we got a comment saying, hey, it's a good
Thank,
chat.
thank you.
And somebody is really asking this, what's that thing on your Vivek Raja's head, which is
Yes.
the product
Our
which we discussed, so which is great.
NexStem headset. Yes, this is our NexStem
And
headset that is capable of capturing your brain signals and transmitting it. So, yep. And yep, I can wear it for a very long time. So, that's how it's comfortable to wear as well. So, you can do all your long processing experiments, data recording, and training, and even accessing your brain signals or your applications with that headset. And it's very plug and play and easy to wear. Yep.
cool. So we can wait for 2 more minutes. If there are any questions, we can take those questions. Apart from that, Vivek, thanks for coming in and sharing this whole thing with us. Definitely, it was a great learning for me. Coming from a background of DevOps, having a discussion on brain-computer interface is completely different, and I could definitely see this, and probably you can bring those device to Reactor someday whenever you are
Sure.
there. We can try it out. We can try it on Path. By the way, Path is
Uh,
there,
yes,
and he's
definitely.
still in the background. So cool,
Parth
cool.
is one of our potential customers in future. So we have been actually planning to showcase this product in Reactor, and Parth is a most interested person to try it out for sure.
Yeah, definitely. Cool.
Yes.
Okay. Thank you, everyone. Thanks for
Thank you. Thank you
tuning
all. Thank you
in.
so much.
I'm just
Thank you, everyone. Take
bringing.
care. Bye.
Thank you. Thank you. Thank you,
Thanks
Vinayak,
all.
for
Thanks
being here.
everyone. Thanks for
Bye.
having me. Thank you.